This video is going to cover chapters 13, 14, and 15 in the SAS Base Certification Guide. Chapter 13 deals with functions, 14 deals with loops, and 15 deals with arrays. Let's start out with functions. SAS has literally hundreds of functions available to you, and they introduce you to a couple dozen in the chapter, and I'll basically follow along with the chapter. So they've broken them up into types. Many of the types we're not going to get to, but here are a few of the types. So the first one is under the heading of Descriptive Statistics or Summary Statistics. And so SAS offers the ability to, to count the number of valid values. That's with the n function. The number of missing values in a set of variables is n miss. If you want to add up some variables, you use the sum function. You can find the mean of some variables, the minimum value, the maximum value, the variance or the standard deviation. And one really important thing to note about these functions is the way that they treat missing values. So the easiest way to express this is with a simple example. So if we evaluate the sum of 1 and missing, so what is 1 plus missing using the sum function? The answer is 1. All right, so the point is that SAS ignores missing values and returns the sum of whatever is there. Now let's contrast that with using the plus operator. So if we take 1 plus dot, what you'll get in SAS is missing. So let me illustrate some of this with a little example. And so let's say we have three variables, x1 through x3, and what I'm going to do is I'll read them in, and then I'll find the sum using the sum function. Now, sum1 and sum2 both use the sum function. I'm going to illustrate how you can specify a range, and you do that with the of statement. So here I'm saying sum of x1 through x3. Not a big deal to type in x1 comma x2 comma x3 as I did in the line below, but if I had 50 variables, I wouldn't want to be typing each one of them in. So the of and the dash operator is very useful. You can also use a double dash. I could also list x1 space x2 x3 after the of, and that would also work. Okay, sum3 is going to be using the plus sign. Now let's just go downstairs, and you're going to note that I peppered this data set with some missing values. So let's see what happens. So if we take this first row, we have 1 and 2 and missing. So what is the sum of 1 plus 2 plus missing? Well, using the sum function, it's 3. Using the plus sign, it's missing because you've got one missing value. This next row has 3 valid values, so the sum of them is clearly 9, and you get 9 with any of the methods. The next row is completely missing, and of course the sum with any of these is missing. The next row has only one valid value, which is 3, has 2 missing values, so of course the sum function is going to evaluate to 3. The sum3 using the plus signs evaluates to missing. Let's now look at a few other functions in here. Mean operates the same way as sum, so mean is going to evaluate the mean of whatever it has. So in particular, if we go down to this row where it only had one valid value, 3, the mean of 3 is 3. If we look at, for example, the first row, it's going to take 1 plus 2, which is 3, divide that by the number of valid values, which is 2. So the mean of 3 divided by 2 is going to be 1.5. And then in that second row, the mean of 4, 3, and 2 is 3. The n function counts the number of valid values. So notice that first row has 2 valid values, the second one has 3, the third has 0. The n miss function counts the number of missing values. So the first row has 1 missing value, the second has 0, the third has 3. Finally, if we use the standard deviation function, that tells us what is the the standard deviation of the values listed in this. Sometimes I'll do this to evaluate whether somebody is taking my survey seriously. So if I have a survey and I have 50 attitudinal questions, and somebody answers the same thing to each of those questions, that probably means that they didn't take my survey seriously. They just checked down the column and that was it. So I can detect whether they answer the same thing to all questions by evaluating the standard deviation. So the standard deviation of that last person is 0, indicating that they checked the same box for each of the questions. Okay, so that's summary statistics. Let's move on. The chapter also talks about numeric string conversions. So often you have a number and you want to be able to make that into a string, or you have a string and you want to turn that into a number. So to illustrate this, I have a little data set where I've read in a number x and a string s. Now we can use the put and the input function to convert these. So put puts out the value of something with a format. So for example, if I say put x with the format 5.2, what that's going to do is it's going to return a string that, well, in this case it's going to display x with 5 characters and 2 decimal places. And so it's going to print x with 5 characters, 2 decimal places as a string. So let's go look at what happens. Notice that x takes the values 1, 2, and 3. X string then is 1.00, so the 2 decimal places come because of that 5.2. Now I could display this with any format that I like. Let's make another version of x where I'm going to put it this time using the dollar format, and we'll display it with 4 characters. So here you go, $1, $2, $3, cool. Input does the opposite of this. So input says, go take some string argument and input according to this format. Now best just means take the best numeric format that SAS thinks is appropriate. And so snum, so this is going to be s as a numeric variable, it's going to take the value, we're going to input from string s some number. And so now snum is a number. So that's how you convert numeric variables to strings and vice versa. Let's talk about dates. Now we've already talked about most of these functions, but as long as they're in the chapter, might as well cover them, and it's not going to hurt us to go over them again. So how do we create a date? Well, one way, the way that I tend to use, is to specify it as a date constant. So if you say in double quotes 20 Jan 2011, follow the quotes with a D, that tells SAS that this string 20 Jan 2011 is really a date, and then it will evaluate that to the number of days that have elapsed since January 1st, 1916. That's how that constant is stored. Alternatively, there is a function, MDY, almost like an SPSS, where you could give the month, the day, and the year, and this would return exactly the same thing as this date constant. Sometimes you want to find out what today's date is. You can use either today or date. I don't exactly know why SAS offers 2 functions, but it does. Sometimes you want to strip off part of a date. So this is just like the date extraction functions in SPSS. Day strips off the day part. Quarter would strip off the quarter. Weekday would tell you 1 through 7. I believe 1 is Sunday, 7 is Saturday. Month strips off the month part, and year strips off the year part. So that's how you would strip off various parts. I should mention that if all you're going to do is one run, so let's say I'm going to use proc means and I want to find the response rate by month. It's much more efficient to use a format. So I can use the month format than it is to do what you would do in SPSS, which is first create a new variable indicating the month and then run compare means in SPSS or proc means in SAS. The reason that formats are more efficient is because you only take a single pass through the data. If you first create a new variable, month, you have to take one pass through the data, then you have to run proc means and you take another pass through the data. Whereas if you use a format, you're only taking a single pass through the data, and I've given you some examples of that earlier, and I'll make sure that you get an exercise on that later today. Another task that we often want to do with dates is to compute differences. So the way I've shown you so far, and the way that I tend to do it, is just simple subtraction. So if I have two date variables, D1 and D2, and I say D1 minus D2, that's going to give me the number of days that have elapsed between those two dates. There's also a function, int check. I don't quite know what that stands for, but this will compute the time between 2 days. So D1, D2, and you can give a unit just as you can in SPSS with the date diff function. So this is just like date diff. So you can express the difference in days, months, quarters, years, semi-annually I think is another option. But anyway, let's look at a little example. And I've read in a date. So D1 is a date, and I've got 3 of them. And we'll slap a format on it so that it gets printed just as we read it in. And then you'll see where I've stripped off various parts. So the day, the quarter, the weekday, the month, the year. And I've found some differences using different approaches. So you can get the difference in months or years, and you can study this output yourself and convince yourself that these are functioning as you would expect them to. Let's move on.